Friends, welcome to my YouTube channel. Dhanesh here. In this video, I am going to discuss about the implementation of convolutional neural network using Python, Keras, and TensorFlow. So this is here we are discussing about the CNN implementation. So the softwares I am using here are, I used Anaconda. On top of that, I installed TensorFlow and Keras. So these are all the softwares I am using. All are open source and it's easy to install these softwares. See, Anaconda version 3 only I am using. So these are all the softwares I am using for this implementation. And see, the convolutional neural network, you are familiar. Here you have the different layers. First one is the convolution layer. Convolution layer is there. Then you have the ReLU, rectified linear unit. Then you have the max pooling layer, and the fully connected layer. So these are all this is the fully connected, means it's the feed forward neural network. So these are all the 4 layers in a convolutional neural network. You are familiar with that. Here you will do the convolution operation. See, I have all the videos, separate videos for all these layers. You can watch those videos as well. See what is happening in convolution. We explained in separate videos. ReLU, it is an activation function, max pooling, fully connected. Before getting into the fully connected layer, we will do one operation flatten. We are using Kera's libraries to do this as well. So all these things we explained in the previous videos. So now I am getting into the implementation part using Python, TensorFlow, and Keras. So I am using the Jupyter notebook for the coding. See, I will open the Jupyter notebook. It's here with me. So first I am importing NumPy. Import NumPy of these libraries we need as np. Then I am importing import matplotlib. It is you have the matplotlib, yeah, matplotlib dot you have the pyplot. I am using that as plt. That's also we have. Then you can use this this thing, percentage matplot lib. We will line inline. So I imported whatever needed. So I just imported all these libraries. Now I am importing Keras, Keras, import Keras. Now we will check the backend. You can check the backend as whether, see, backend you can use TensorFlow or Piano, so different software. So you can use it. Here I am using TensorFlow backend. It is dot. You can check the backend. Yeah, I am checking it. So you at that time it will give you the backend. See, using TensorFlow backend. So this is what we are getting it, TensorFlow as the backend. Now we are using this fashion dot the data set we are using is the MNIST fashion .mn. I will show that URL so you will get more idea on that. It is you have this URL, you can use it. So from here only I am downloading the data set. See, here you have this this I can, so this is the data set. From here, if you scroll down, you will get the data sets. See, MNIST. See, this is the fashion MNIST database of articles. You have the t-shirt, trouser, pullover, dress, coat, sandal, shirt. See, you have the label as well: 0, 1, 2, 3, 4, 5, 0 to 9, 10 articles are there. So we are using these images for image classification. This is the data set we are using, and they have given, you can see here, they have given how we can use this data set from Keras.dataset import fashion underscore MNIST. So the same code only I am using in my Jupyter notebook as well. See, it's here. It's I will cancel this. So I am from Keras. I am importing. See, I have the code here. I am importing this data set. That is, I will use this code for importing this data. So this is what. So as I have shown you, I am importing all this data from this fashion underscore MNIST. So that's done. So this is the data I am using. So I am using this x underscore train. See, we have y underscore train, the training data, and the testing data we have got it from the fashion underscore MNIST, and we used the load data. That is the function we are using here, and we have taken the 80%. Normally the 80% of the data will be used for training, and the 20% of the data will be used for testing, that. Then I can see this x underscore train dot shape. If I am running this code, you can see the it is around 60,000. It is the size of the the data set. You can get it from this x underscore train dot shape. So you understood that. And if you want, you can see here plot dot this method you can use. If you want, you can use x underscore train. Then we will take the first step. So if you run this this one, this is the this is the one. See, if you see the the data set here, it is you can see it here from the fashion MNIST. So these are all the data. You have t-shirt, trouser, pullover, dress, coat, sandal, shirt, sneaker, bag, ankle boot, everything is there. So by changing, if I am changing it to 0, you will get it as this one. So you can get it. See, it's a you can get it here. See, this is the one. See, you can see it here. You can compare and you can understand this. So this is the the data set we are using. We have the plot.match show that a function will give you the image. And now you can, if you want the train, if you want, you can use this also, y underscore train. Then it is 1. If you run this, we will it's see, it is what we used here, it is 0, right? In the previous case it is it's 0. So I am using it here also, the 0. For the ankle boot, it's 0, and I am running it, Then here you will get the label. So we will check the label. See, it's 9. Angle boot, it's 9. The label is 9. So we got the label by using the method y underscore train 0. That we got it. See now, see this, if we normally all these, the arrays, it's in the, it should be 0 to 255, the size of the pixel size, it ranges from 0 to 255. So to convert it into, between 0 and 1, so to convert the values, the size of the image, how computer represents image, it will, it has 3 channels, and the values ranges from, the pixel values ranges from 0 to 255. So these things. So what we are going to do here, it is we divide with 255, then you will get all the values between 0 and 1. So that's what I am going to do now. We are going to divide with all the data with 255. So you will get it as like this. So now I am doing that operation. So it's the symbol, it's what I am going to do here is the pixel values ranges from 0 to 255. I am dividing with 255, then the values will be between 0 and 1. If you run this code, you will get it as see, if you see this, all the values are between 0 and 1. So normally, if you, without doing this operation, if you are printing, it ranges from 0 to 255. So we have done it to minimize the things, so it will be easy for us now. Now I am importing the Kera's sequential, and all these layers, dense, activation, flatten, all these layers I am going to import now in my neural in my program. So for that, so you may be familiar with, I already explained you, we have this sequential model, it's from the Keras, and you have this dense, activation, and flatten layer. See, activation, it's for the activation function, and flatten it's the process, in convolutional neural network, the input to the last layer, the fully connected feed forward network is the is a 2 by 2 matrix, or a 2 by it is a sorry it is a map of a dimension, it can be 2 by 2 or 3 by 3 or 5 by 5. So that map, it's a matrix, it's converted into a tensor known as vector using the flatten operation. That is before getting into the fully connected layer, it is a feed forward neural network. Before getting into this network, we will do an operation known as flatten. Flattening is the process of converting a 2-dimensional matrix into a tensor known as vector. Vector is a it's a single it's a consists of a row or a column. So that process we call it as flattening. And dense layer is the regular layer of neurons in neural network in Keras. It has a weight matrix W and a bias vector B. So that's the dense layer. So these are all the different layers. So we imported those layers from this Keras, and so we are getting one import error, that is I think it's with flatten. So let me check it. Some import error we are getting. See it's here, it's a flatten, F must be capital, sorry. So we will again run it. Now it's fine. So this is, we have imported from Keras all these things. Now you can add all these things. See, I am adding, see, even you can use it in the constructor as well. Inside the sequential constructor you can add these layers. So I am adding all these layers to the code. So it would be like this. You can do it. So here it is model is equal to sequential. It is model. This is the 1 second model. So even this flattened dense you can show here as the inside the constructor, you can show it, but I have used model dot add flatten dense layer. I have already told you. Relu is the second layer. It is the rectified linear unit. So the second layer, what is the purpose of the second layer in convolutional neural network? It will remove all the negative values. That's the purpose of the Relu activation function. Next is the softmax. Softmax is another activation function. It's also known as soft argmax or normalize the exponential function. All these things are same, softmax or soft argmax, or we also call it as normalized exponential function. A function, this softmax function, it takes input as a vector and normalizes it into a probability distribution, and it normalizes it into a probability distribution. And this this probability it will take the exponents of the input numbers. It is this probability distribution contains the exponents of the input numbers. That is the softmax activation function it do. So that's what we are using here. All these Relu softmax, you understood. It's softmax, it takes us the input as the vector. I told for after flattening operation you will get the vector input. So that vector it will take and normalizes it into a probability distribution which is proportional to the exponents of the input numbers in the fully connected feed forward network in the last layer. That's the softmax activation function does. So that also you understood. Now we will call this model dot summary, and we will compile this. This we are going to compile it. So for that I am using this piece of code. It's actually very simple. You can from this you can build more interesting. See, I can see all the layers. See how many layers I am using, everything you can see. I'll let it be. We will start with some layers, neurons. The number of neurons in the dense layer, I am taking it as 20, and the activation is Relu activation. Here it is softmax, flatten, everything. See, I am using these are all, see everything, every data it's given here. See, you can see it here, whatever things it is, I am doing it here, everything you can see it here. Just 1 second. So you can see it here. After that I am running this. So all the details you can see it here. Dense layer, it contains 20 and it contains 10 neurons. All these things it's shown here. So now what I am we have compiled the model, the machine learning model. We compiled it. Now if you see here, this is the the loss function we are using is the cross entropy. That is the loss function or the error function we are using is the cross entropy function, and the optimizer we are using is the Adam optimizer. And here you can specify the inside this bracket you can specify the learning rate as well. See, learning rate, you may be familiar, it is the the size of the a baby step you are using to even you can modify this program inside the Adam optimizer. Inside the bracket you can specify the learning rate as well, and you can change the program in your own way. So that is the another thing. So now I am going to called the fit function. See, you have this function, model dot, yeah, you have it. So I am going to do that. So here I am calling the fit function. It is C. So now we are training the model. See, that's what I told you, it's I am training the model. The box, it's 5, so it's we are giving the iterations, 5 iterations, and the learning rate, if you want, you can use it here. Learning rate, its value ranges from 0 to 1, that, so you can use 0.001 inside this Adam optimizer. You can use the learning rate as well. So it's it's training. We are now training the model, so it's done. So now we will call this function. This we have used test underscore 0, right? Everywhere it's let me check it 1 second. Yeah, correct, 0 only. So I am going to use this function. It is 1 second. We will copy it from here, otherwise it will take a lot of time. So I am copying it from here. I will call this. So it would be, you can run it, so you can see inside the test data, this is, see, we trained it, and the testing data could see that it can recognize the image. The test data it's showing is that's what you could see it. It could identify the image. It's coming as the angled board, and even you can what you can do is you can call this function as well. See, you will get more clarity on this. So it would be like when you are doing this, x underscore test shape, so dot shape x underscore test. See, here you have the x underscore test, or you can use this function. What you can do is plt dot match show x underscore test, or you can it's 0, right? Yeah, we will run this, then so you can see it as we have got it. Now we will use the model to predict it. See, let's have our prediction, y prediction. We are prediction, we are predicting, if we are writing it as y prediction is equal to model dot predict, then you will get x underscore test. So then we will run this. It is, now we will see what is our predicted model. ypred, we are checking the value of 0, the y predicted 0. Then you can see this array. See, if you see this array, even if you know the convoluted neural network, how it is identifying different letters. See, in the vector, some specific values, when you convert this, the map from the previous layer, that is the max pooling layer, to a flattening operation you will do, and you will convert it into a vector. At that time some specific values will be high for a particular image, and some other values will be high for some other image. This is the way the convoluted neural network identify some specific images. So if you see here, so which one is high here? See here it is, you can see this 9.0047, this value is high for this image. So if I take that, if I can I can even print it. It is I am using it as np, this function. If you are using arg max, max, then our ypred, it is 0. If I am checking it, if I am running it, what you can see here, it is, see, it's 9. You got that value. So some it is the same, you can see it in the data set as well. It is the angled boot, it's 9. So if we use this function evaluate is there, then you can use x underscore test comma y underscore test. If you run it, you can see the loss function as well. Now it is we have 85% accuracy, we have 0.851, and now you can change the learning rate, you can change it, and the number of layers. See, one option you can do is here, if you change the number of layers to some 200, I can check 1 second. If you are changing it up to 200, you can again modify this program. See, for that, if you are running from here, it is run it, then run it. See, if you change it, okay, now here you have, if you are putting 200 here and you are running it, and if you check again, we are training the model once again, because one is you can change the learning rate, that is you can give it in the Adam optimizer. There you can specify the learning rate 0.001 and again change it, but like that these things you can do it yourself. See, you can change it again and again, you can check the loss function and the accuracy, you can see it. So now previously it was around I have told you it was around how much it was, 85. Now we will check it again. Now we are training the model once again. Let's wait for that. Again, another option is, now I have changed the neurons. Another option is inside the Adam optimizer. You can see here, you can include the learning rate inside the bracket. You can include learning rate. LR is equal to some 0.001, like that. You can specify this value. You can, the value of learning rate changes from 0 to 1. What is learning rate, I already told you. So like this you can train the model. So that's what we do. Now again we are checking it. we call the fit function. Another function you can use is fit generator. So that function also you can use. I am using model.fit. Here the number of iterations is 5. So yeah, it's done. Now we will then we will again check it. Okay, see, we got 0.88. Again, it's increased. So like this, so what I am telling is change the number of neurons, change the learning rate, and you can train the model and you can but this is good. 0.8892 is a better one. So this here we have used the convolutional neural network for image classification. So thanks for watching.